Good morning. Today's let us discuss about timing diagram in 8085. What is meant by timing diagram? Timing diagram is graphical representation of how an instruction is being executed. So if you have an instruction, what is the step by step how it is being executed is diagrammatically represented, which is called as timing diagram. Execution is basically done with respect to time. So in each clock pulse, 1 by the clock pulse is nothing but t state. For each t state, a particular task is being completed. So before going into execution of an entire instruction, we should know what is machine cycle. So an entire instruction is not being executed in a single stage. It is being divided into so many number of stages. Each stage we will call it as machine cycle. In 8085 there are 5 machine cycles. Time required to access the memory or input output device is called machine cycle. So in an instruction, you will more than one time you will try to go and fetch the data from the memory. So each time you can go to memory or input output device, we call it as machine cycle. Okay. So I have told that there are 5 machine cycles in 8085. The first one is opcode fetch. All the instruction should have opcode fetch, and the remaining is optional depending upon the instruction. If it is a single byte instruction, only opcode fetch will be there. So only if you fetch the opcode, the task is over for a single byte. So from the word itself is clear, it is single byte. Okay. In 2 byte instructions, there can be one opcode fetch followed by either you will have memory read, memory write, input output read, and input output read or write. Okay. So 2 byte instructions will have one opcode fetch followed by 1 or 2 memory read write or input read input write. Then next comes 3 byte instructions. So in case of 3 byte instruction, you will have more than 1 or 2 memory reads and memory write. Okay. Let us see one by one. First let us see what and all how each and every machine cycle is being executed with the help of timing diagram. Then we will see an instruction which contains all this opcode fetch, memory read and memory write. Okay. Now what is machine cycle? The process takes a definite time to execute the machine cycle. Time taken by the processor to execute machine cycle is expressed in terms of t states. Yeah, each clock will have a rise time, then in steady value, then again fall time. One rise plus one fall duration is called as one t state. You have to start from 0 condition, then 1 condition. Okay. So we should clearly know the control signals. Control signals are the signals which indicates what type of machine cycle operation is being carried out. Please see here, if it is, there is a pin in microprocessor which is called IO bar M. Okay. This IO bar M is nothing but input output or memory. It is saying whether you are going to read from input output device or from memory. Okay. Then S1 and S2 are called as status signals. This status signals will tell whether what type of operation it is. Okay. Now let us see for opcode fetch. For opcode fetch, it is opcode is fetched from memory. So obviously this input output, if it is from input output, then it will be 1, or if it is from M, it will be 0. This M is active low, whereas input output is 1. So for an opcode fetch, this is 0, whereas S1 and S2 signals are 1. Next to opcode fetch is memory write. In memory write, again it is from memory, it is saying, so this M should be 0, so we have put in 0 for that, and S1 is 0 and S2 is 1. See, this logic is being predefined. S1 and S2 logic is predefined. So based upon that S1 and S2, we are able to identify which mission cycle is being carried out. Okay, this is for memory write. I told for memory read, see again it is memory, so it is 0. Then for write it is 0 1, for read it is 1 0. Okay, the same will repeat for input output write. Only difference is here instead of M I am going for input output. So if you want input output, then this pin should be 1. So this pin will be 1 for both input read or input write. This pin will be 0 for both memory read or memory write, and the remaining is same. When you go for write, S0 is S1 is 0, S2 is 1. For read, what you have written for memory read, same case, it is 1 0. Okay, now it is easy. When you go for opcode fetch, both S1 and S2 are 1, and it is from memory, so 0. Then common for memory read and memory write, that IO bar M pin is 0. Then for write it is 0 1, it is read it is 1 0. Same case for input output read. Okay, this interrupt acknowledge is sequences S1 and S2 are 1, and input output device, from input output device only you can get interrupt. Interrupt will not from memory, so that is 1. Okay, then alt is nothing but the last line of the program where it is saying indication of the termination of the program, so that is all are 0. Okay, so these are the control signals which we should know, that by control signal we will identify which is operation is being carried out. Okay, first let us see opcode fetch. Opcode fetch, this instruction of the processor as 1 byte code. See, opcode is nothing but it is going to explain what type of instruction is it is. See, there are pre-written all the instructions in the memory. So by reading this opcode only, microprocessor will understand what type of instruction it is. To differentiate between opcode fetch and other mission cycle, only for opcode fetch you require 4 T states. Okay, in which first 3 states are used and 4th T state is mandatorily left free to identify whether it is opcode fetch or remaining mission cycles. Okay, so let us draw the timing diagram. So first of all, I have told you require 4 T states. So put the signal as T1, T2, T3, T4. I have drawn the clock. Clock, please see it is at 0, 1, 0, 1, 0, 1, and it's go on. Okay, now please listen. We have higher order address, lower order address. Lower order address is alone multiplexed with data lines. So there is a person called ALE. This ALE is going to separate the address as well as data. So initially you required an address. See, when you have an instruction, this instruction will have an opcode. This opcode is being written in a memory location. So to go to that memory location, I should know the address. Address is 16-bit. So initially both higher order and lower order will tell the address. Once the lower order and higher order has told the address, then lower order can be converted into data lines. So that is done by ALE. So once this ALE signal is brought low, the address lines now will becomes data line, and it will shows the opcode which is being fetched from that particular memory. Then whether it is write or read, in case of opcode fetch it is only read. You are going to read from the memory, so write signal is not required, and input output bar M is your active signal or control signal which we have seen in the previous slide. So first what I had told, for the first clock pulse, both higher order and lower order will tell about the address. Then once this address is being obtained, or now clearly understand, this address tells the opcode address or opcode location. Okay, so once this is being address is being obtained, we will bring the ALU to 0. Then we will have input output lines as a control lines which we have seen. Again, now we are not reading anything, so this will be in active high. So for the next clock pulse, what happens is, the higher order address there won't be any change because it is only meant for address. So till the last T state, the higher order address will be in the higher order address itself. Whereas see, lower order address lines is converted into data lines. Now it has an opcode. Now this opcode has to be read from the memory to the microprocessor. So your read signal is being brought down. See here, now the read signal is being brought. Once read signal is brought down, this opcode is read by the microprocessor from the memory to the inside your processor. So we have seen what should be the control signal. Since it is from memory, M should be 0, S0 and S1 both should be 1 for opcode fetch. I think you are now able to understand what is an opcode fetch machine cycle. I will repeat, opcode fetch machine cycle is nothing but opcode will be written in a particular location. That location address you need. First step, in first T state, we will read the address. Once the address is read, AL is brought down. Once AL is brought down, address lines will become data lines. Once you get the data that is to be read or write, you have to specify. In case of opcode fetch, it is only read. So you are reading with the help of read signal brought down. Okay. So similarly, we will see for memory read. Memory read is next to opcode fetch. Some instruction will say there is some content which is to be read from the memory for the completion of the entire execution. Now be clear, only for opcode fetch it is 4 T states and remaining is only 3 T states. Now please listen, what should be on the T1? Both should be on address, then AL is brought down, then control signal we should know. Control signal I have told already, it is 0, S1 is 1, S2 is, a small mistake is been here, this is 1 and this is 0, it is written both as 1. Okay, now you will read it. So once you read it, opcode is been brought in, opcode is been moved to your processor. Next come memory write. So memory write is also after, for an example, if you have an instruction called STA 4500, what it says, the content of accumulator is moved to 4500. So at the last machine cycle, there is a write operation, which means content of microprocessor is being written inside your memory. So that type of operation is called as memory write machine cycle. Okay, in memory write instruction, see again on the first T state, both address is being brought in. Once both address is being obtained, AL is brought to 0, again it will become data lines. So now please listen, till this instruction we were seeing with respect to only read and this is write. Okay, so this write signal will be brought. See, all read and write and ALE are active low signals, so they will be performed only if the signal is being brought to 0. That I have already told. Why the signals are working on active low is, any signal which is going to decide the operation is usually kept in active low, because external signals or noise should not disturb this pin. See, if you keep this read or write in active high without your permission, it will be saying your processor to read or write because of the noise which are present in the environment. Next comes input read. There is no change between memory read and input output read. You have to know what is the difference. It is very simple difference. That is, there we will not say it as port address, we will say it here it as port address. What is input output read and memory read is differences. There are some peripherals which is connected to the microprocessor who have only 8-bit address. This 8-bit address or 16-bit address from the external peripheral we bringing as an input output ports. Okay, via ports if it is coming, only difference is you have to tell it as port address, where there we will just call it as higher order address and lower order address. Here we call it as port address. See, remaining is same. During first T state, both both higher order and lower order will tell about address. Then as usual we have to bring ALE to 0. Once you bring the ALE to 0, your lower order address lines will become data lines. Then whether you have to see whether it is read or write. If it is read signal will be brought and read signal will be brought low. Okay. Then for write signal will be brought. For read signal you keep read signal here. For write you keep your write signal here. Let us see two examples of an instruction. See, first instruction, let us see LDA 16-bit address. Okay. Now for this LDA you will have an opcode fetch. Then 16-bit address you will have to memory read, because that 16-bit will be written in your memory location in two location, higher order of this address, then lower of this address. Then you have to see what is the instruction says. What the instruction says, load the accumulator from the memory address. So it is again a memory read. I will repeat. Please here, LDA is opcode fetch. Then you have 16-bit address. You are going to say the address from where the content is to be loaded to accumulator. So this address has to be read by your processor. So it takes to memory read, followed by the final value what you are saying, bring it to accumulator. So that is again a memory. So please see here, you will have higher order address, lower order address, opcode. Okay, first work is done. Then again ALE is brought high. Once ALE is brought high, it is to address. So that address, then followed by you will bring down ALE, you will get data. This data is nothing but 16-bit content here is split up here, one first part, then second part, then finally from the memory location the data is transferred to accumulator. Just we will see one more example, STA 526A. So first is opcode fetch for STA, then this 6A is a memory read that is been done, then 52 is again a memory read, it is been read, then followed by STA, that means accumulator content is stored in the particular location. Okay, so that is drawn here. Thank you.